the first movie we translated into DNA. It was like a movie of a Space Invaders, 2 frames. And the idea was a little bit like, because it's always a problem if you have like a dynamic spatial system like the DNA, you know, you can imagine it like very dynamic and spatial, to translate it to a 2-dimensional format. We try still to have a grip on the dynamics by using film and not just single pictures. On other occasions, we use like interactive installations to own up to the how you can say, to the nature of the DNA. So this was like the move. Let's go back to here. So here I can give a little demonstration. So I just have here a random picture. And here, okay, it was too much. It's okay. So this was our first software converting this picture that just showed you into a string of G, T, A, and C, which are the ground bases of the DNA. And you can send this to a laboratory and they synthesize it for you, and you have the digital picture as a molecule. So the order of the molecules it refers to the order of the colors and the position of the pixels. Okay. So let's go back. So this was our first experiment. And in our second experiment, which is called Mutants from Inner Space, we took again 2 frames, like movie, translated it to DNA, put it in vitro in E. coli bacteria, and let them mutate. So later then we took it out, retranslated it, and then you could see the mutations in the picture. So this is frame 1, here's frame 2, and here are the 2 frames of the first mutation. So you can see a big deletion inside the middle, and this just refers to the curves. It's always, you know, it's DNA visualization software, so it's quite the same there. In the second thing, we have only, as you can see, 3 pixels were like changed, so there were only mild mutations in that form. And the third experiment we could make with this topic was the fake lambda simulacrum. We showed here in this interactive simulation. In this work, let me see,